Everyone, please put your presentee now. Yes, done with your presentee marking. All of you have done. Okay, so let's revise whatever we have done till now in our lesson number 5 inside the atom. Okay, we have learned what is meant by matter, then what is atom, and what is the smallest unit of matter. So, can you explain what is Dalton's atomic theory? Yes, anyone can explain what is Dalton's atomic theory? Miss Mansi? We are just revising because too much gap is there. That's why. Okay. Yes, Mansi, you can answer now.
According to Dalton's atomic theory, matter is made up of atoms and atoms are invisible and indestructible. All atoms are all atoms of an element are alike while different elements have different atom with different mass.
Okay.
Is it the correct answer?
Yes. And anyone who will explain Thomson's plum pudding model of atom? Thomson's plum pudding model of atom. Yes, Nidhi?
Yes, ma'am. According to Thomson model, the positive charge is distributed throughout the atom and a negatively charged electron are embedded in it. Distributed of a positive charge is balanced by negative charge on the electrons. Therefore, the atom becomes electrically neutral.
Yes. And can you explain the experiment by which Rutherford confirms its nuclear model of atom? What he did, what Rutherford did to explain his nuclear model of atom? What experiment he done? Yes, he bombarded the particles. Do you remember that? Yes, anyone? Okay, explain the Rutherford's nuclear model of atom. Yes, Mansi.
Yes. An atom has tiny, dense, positively charged nucleus at center of an atom. Most of the mass of the atom concentrated in the nucleus. Negatively charged particles called electrons revolve around the nucleus. The total negative charge on all the electron is equal to the positive charge on the nucleus. As the opposite charges are balanced, the atom is electrically neutral. There is an empty space between the revolving electron and the atomic nucleus.
Okay, so this was all the specification of Rutherford's model of atom. Okay, I'm asking what experiment he did to get all those points. Just now Mansi has explained. हे सगळे पॉइंट्स त्याला न्यूक्लियर त्याच्या न्यूक्लियर मॉडेल ऑफ त्यांनी जो ॲटमचं न्यूक्लियर मॉडेल बनवला त्याच्याबद्दलचे फॅक्टर्स मानसीने सांगितले बरोबर. पण त्याने हे सगळे फॅक्टर्स मिळवण्यासाठी नक्की कोणता एक्सपेरिमेंट कॅरी आउट केला? कौन सा एक्सपेरिमेंट कैरी आउट किया था उसने? व्हाट ही डिड? Okay, Mansi again. Yes, Mansi.
He does the experiment that he took a very thin gold foil, thickness is 10 raised to minus 4 millimeter, and bombarded it with positively charged particles emitted by a radioactive element. He observed the path of alpha particles by means of a fluorescent screen around a gold foil. It was accepted that alpha particles would get reflected from the gold foil if the positively charged mass were evenly distributed inside the atoms. Unacceptedly, most of the alpha particles went straight through the foil. A small number of alpha particles get deflected from the original path, a small angle. A still smaller number of alpha particles get deflected throughout a large angle, and surprisingly, one alpha particle out of um, 20,000 bounced back in the direction opposite to the original path.
Okay. Okay, this was the experiment which was done by Rutherford. Okay, what were the important postulates of Bohr's atomic model? What were the important postulates of Bohr's atomic model of atom? Yes, Nidhi.
Yes, ma'am. The electron revolving around the atomic nucleus lie in the concentric circular orbit at certain distance from the nucleus. Energy of an electron is constant while it is in a particular orbit. When an electron jumps from an inner orbit to outer orbit, it absorbs energy equal to difference of its energy level, and when it jumps from an outer orbit to an inner orbit, it emit energy equal to the difference of its energy level.
Okay. Now, what are the three types of subatomic particle? What are the three types of subatomic particle? Yes, Mansi.
Nucleus, proton, neutron.
Okay. Tell me something about proton. Anyone? What is proton? If you are asked to write a note on proton. Yes, Nidhi.
Yes, ma'am. The proton is a positively charged particle denoted by symbol P. Small p. It is located in the nucleus of an atom.
If you are asked to write a note, नोट लिहायला सांगितली तर एवढंच लिहिणार का त्याच्यामध्ये? येस. येस निधी, कंटिन्यू.
Yes, ma'am. Proton is a positively charged subatomic particle in atomic nucleus. The positive charge on the nucleus is due to the proton in it. A proton is represented by symbol P. Each proton carries a positive charge of plus 1 is equal to 1.6 into 10 minus 19, 10 raised to 19 Columbus. When total positive
कुलोम. कुलोम.
Coulomb. When total positive charge on a nucleus is expressed in a unit E, its magnitude is equal to the number of protons in a nucleus. The mass of one proton is approximately 1 Dalton. 1 Dalton is equal to 1.66 into 10 raised to 27 gram. The mass of one hydrogen atom is also approximately 1 Dalton.
Okay. If you are asked to write down note on electrons. Mansi,
Yes, ma'am.
electrons.
The electron is negatively charged particle denoted by the symbol minus E. The charge of the electron is treated as one elementary unit of negative charge. Electrons revolve around the nucleus of the atom in specific orbits.
And
And mass of an electron is 1800 times less than that of a hydrogen atom. Therefore, the mass of an electron can be treated as negligible. Electron is an extranuclear part revolved in the distinct orbits around the nucleus. The orbit being three-dimensional in nature, a term shell is used instead of the term orbit. The energy of an electron is determined by the shell in which it is present.
okay. Okay, till here we have learned about, right? See, as we know the mass of an electron being negligible, therefore the mass of an atom is mainly due to the proton and neutrons in its nucleus. आपण पाहिलं की इलेक्ट्रॉनचा जो मास आहे तो काय आहे नेग्लिजिबल, काउंट न करण्या इतका आहे. म्हणून एखाद्या एटमचं जे वस्तुमान आहे, मास है, किसी भी एटम का जो मास है वो किसके ऊपर डिपेंड रहता है, उसके अंदर जितने प्रोटॉन एंड न्यूट्रॉन्स है उस पर डिपेंड करता है. द टोटल नंबर ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स इन एन एटम इज द एटॉमिक मास ऑफ दैट एलिमेंट. किसी भी एलिमेंट का एटॉमिक मास कितना होता है, उसके अंदर प्रेजेंट होने वाले टोटल नंबर ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स के इतना कौन से भी किसी भी एलिमेंट का एटॉमिक मास होता है. Atomic mass of an element is equals to total number of proton and neutron present in it. The mass number is denoted by the symbol capital A. The convention to denote atomic symbol, atomic number and mass number are together is shown as follows. Okay, A upper case वरती A symbol आणि खाली असणार आहे तुमचा Z. फॉर एक्झाम्पल द कन्व्हेन्शनल सिम्बॉल कार्बन आहे तर atomic number त्याचा असणार आहे, सॉरी mass will be 12 and what is our Z? The number of electron. The number of electrons present in it will be 6. Okay. See, means that the atomic number, that is the proton number of carbon is 6 and the mass number of carbon is 12. From this, it is also learned that the nucleus of carbon contain 12 6, that is 6 neutrons. Okay. See, carbon symbol carbon चा C A आहे आणि Z आहे, like this. See, I will show you. See, here is how they have written A and Z. Yes, carbon. Carbon is our example. 12 याचा अर्थ काय होतो, 6 will be the protons and 12 is mass. Okay, अणुवस्तुमानांक 12 आहे, त्यामुळे प्रोटॉन जितके असतात कोणत्याही एलिमेंट मध्ये तेवढेच इलेक्ट्रॉन पण सॉरी तेवढेच न्यूट्रॉन्स पण प्रेझेंट असतात. म्हणजे 6 12 6 यामध्ये 6 का आहेत, न्यूट्रॉन्स आहेत. ओके. Now distribution of electrons, as we have learned this shell. Yes, these shells K, L, M and L. K shell, L shell, M shell and N shell. एलिमेंटच्या या शेल मध्ये इलेक्ट्रॉन्स डिस्ट्रीब्यूट केलेले असतात. ओके. Yes, here see some questions are there. The symbol used for oxygen is O. There are 8 protons and 8 neutrons in its nucleus. From these, determine the atomic number and mass number of oxygen and arrange these in a conventional symbol. Sanga, how you will find that 8 protons and 8 neutrons are there. So what will be the atomic number? Yes? Anyone? ऑक्सिजन आपण कशाने डिनोट करतो, ओ ने. ओके. त्याच्या न्यूक्लियस मध्ये 8 प्रोटॉन आहेत आणि 8 न्यूट्रॉन आहेत. मग ऑक्सिजनचा ॲटॉमिक नंबर काय येणार? atomic number and mass number you have to find out. How you will find out Z? Yes, how you will find out Z? Proton number, the protons present inside any atom is its atomic number. Yes, its atomic number. So atomic number will be 8. Atomic number will be 8. And what will be the mass number? How you will find mass number? Mass number will be 16. As we will add proton and neutrons. 8 protons and 8 neutrons are there. So mass number A will be 16 and Z will be our 8. मग आता तुम्ही कसं डिनोट करणार? A वर आणि Z खाली आणि मधी ती संज्ञा, मधी तो इनिशियल. मग कसं डिनोट करणार तुम्ही? Yes, how you will denote that? कसं दाखवणार? You have written 16, all of you have written 16, but you have found out 16 as just a mass number. I have also asked you about the atomic number Z. Atomic number is equal to the protons present inside the atom. And how many protons are there? 8 protons. So Z will be 8. So you will denote that oxygen is like 16O8. Okay, this is how you will denote oxygen. Understood? Understood all of you? Okay, now you can find out the rest one. Next topic is distribution of electrons. As we have learned about this shell, K shell, M shell, L shell, N shell. मग त्यामध्ये आपले जे इलेक्ट्रॉन्स आहेत, जो भी इलेक्ट्रॉन्स है हमारे, वो डिस्ट्रीब्यूट किस तरह से होते हैं, दैट वी आर गोइंग टू लर्न. As per Bohr's atomic model, electrons revolve in stable shell. Okay, बोहर ने जो एटॉमिक मॉडल बनाया था उसके हिसाब से वो जो भी इलेक्ट्रॉन्स है वो किसी शेल में, जो भी स्टेबल शेल है उसमें रिवॉल्व होते रहते हैं, घूमते रहते हैं. These shells have a definite energy and इस शेल्स को कुछ स्पेसिफिक एनर्जी इस शेल के पास रहती है. द शेल नियरेस्ट टू द न्यूक्लियस इज कॉल्ड द फर्स्ट शेल. जो भी शेल न्यूक्लियस के नियर होगी, बाजू में होगी, पास होगी, उसको हम कहेंगे फर्स्ट शेल. द नेक्स्ट शेल इज कॉल्ड द सेकंड शेल. उसके बाद वाली शेल को हमें कहना है सेकंड शेल. A symbol small n is used for the ordinal number of a shell. जो काही ऑर्डिनल नंबर आहे शेलचा त्याच्यासाठी लाईक के विल बी इफ द के इज द फर्स्ट वन, द नंबर विल बी 1. ओके, लाईक दिस. ते आपण कशाने डिनोट करणार आहोत? स्मॉल एन ने दाखवणार आहोत. द शेल्स आर referred to by the symbol capital K, capital L, M and N corresponding to the ordinal number 1, 2, 3, 4. K will be your 1, L will be your 2, M will be your 3 and N will be your 4. Yes, got till here? Everyone got till here? Yes? Okay, now the next one. The maximum number of electron a shell can contain is obtained by the formula 2n square. 2n square. एका शेल मध्ये जास्तीत जास्त किती इलेक्ट्रॉन जाऊ शकतात? एक शेल में ज्यादा से ज्यादा कितने इलेक्ट्रॉन जा सकते हैं, हम उसमें रख सकते हैं. ये हमें कौन से फॉर्मूला से फाइंड आउट करना है? कौन से फॉर्मूला से पता चलेगा हमें? 2n square. Keep in mind 2n square. As the magnitude of n increases, the energy of an electron in that shell increases. जशी जशी आपली n ची संख्या वाढत जाणार तशी त्या शेलची एनर्जी, इलेक्ट्रॉनची असणारी एनर्जी सुद्धा वाढत जाणार. जैसे जैसे हमारा n का नंबर बढ़ता जाएगा, जो भी इलेक्ट्रॉन्स प्रेजेंट है उस शेल में, उस स्पेसिफिक शेल में, अगर L में हमारा नंबर ऑफ इलेक्ट्रॉन बढ़ रहा, एन का नंबर बढ़ रहा है, तो वहां पे जो नंबर ऑफ इलेक्ट्रॉन है उनकी एनर्जी भी इंक्रीज होती जाएगी, बढ़ती जाएगी. यस. सी शेल. ओके वेट. ओके. What they have asked you? Shell, then symbol how K, L, M, N and N. N is 1 for shell. Okay. So formula is our 2n square. So number of electron will be 2 only. Yes. 1 square is 1 and 2 into 1 is 1. Like that, can you find out the others? L, N, M, can you find out? Yes. Start writing and after completing let me know. For L, your N will be 2. Yes. For M, your N will be 3. Okay. चला करा पटापट. After completing, let me know. No. Write it in a notebook. After completing, please let me know in the chat box so that we can proceed. Write it very neatly and clearly, please. You can refer it whenever you want. Do not write it do not do any mess. Write it very clearly and neatly. It is not going to waste. You can refer it in any form. Like when you have complete the following tables, you can see how many electrons will be fitted in K, in L, M, N, whatever they have asked you. Okay, Mansi has done. Let others also, and after that, after everyone has completed, then you will write the answers in chat box. Till now, do not write any answer. Okay. Everyone, please do it fast. Yes, make it fast. Mansi, Nidhi, and Hariom. What about others? Veda and Parth Vaibhav. Are you writing or not? Please let me know if you are writing. Otherwise, okay. Whoever have completed, write your answers in the chat box. Denote the shell, and after that the number. Shell liha like yes, like this. K2 L8 M18 and N32. Good. Okay, this was from Nidhi, Mansi, and Hariom. Write yours also. Okay. Now you got how many electrons will fit in that shell? Yes. K will contain only 2. No other electron will go inside K. 2 च्या पुढे कोणताही एक्स्ट्रा इलेक्ट्रॉन K मध्ये जाणार नाही. L will contain only 8. No other electron will get in 8. Okay. Next. Electronic configuration of metal. What is electronic configuration of metal? See, we have seen that 2, 8, 18, 32. Electrons can be accommodated in the shells K, L, M and respectively. Okay, we have found out that. And we have found out it correct also. See, here is the answer. This is the maximum capacity of that cell. ही काय आहे त्या शेलची मॅक्झिमम कपॅसिटी आहे. त्याच्या पुढे ती शेल इलेक्ट्रॉन्स ऑक्युपाय करू शकत नाही. The electrons in an atom are distributed in the shells according to their maximum capacity. मग या शेल्सच्या मॅक्झिमम कपॅसिटी नुसारच ऍटम मधले जे इलेक्ट्रॉन्स आहेत त्या शेल्स मध्ये डिस्ट्रीब्यूट केलेले असतात. ओके, इन शेल्स के जितनी मैक्सिमम कैपेसिटी है उसी के हिसाब से वो जो एटम्स है कोई भी एटम के जो भी इलेक्ट्रॉन्स है वो इन शेल में डिस्ट्रीब्यूट किए हुए होते हैं. The shell-wise distribution of the electron in an atom of an element is called the electronic configuration of that element. Note down, the shell-wise distribution of the electron in an atom of an element is called the electronic configuration of that element. They might ask you, what is called as the electronic configuration of element? You have to answer the shell-wise distribution of the electron in an atom of an element is called the electronic configuration of that element. कोणत्याही मूलद्रव्याच्या अणूमध्ये जे इलेक्ट्रॉन आहेत त्या इलेक्ट्रॉनची शेलमध्ये केलेली मांडणी म्हणजेच त्या इलेमेंटचं इलेक्ट्रॉनिक कॉन्फिगरेशन किंवा इलेक्ट्रॉन स्वरूपण होय. ओके, किसी भी एलिमेंट का जो भी एटम है उस एटम में जो इलेक्ट्रॉन्स प्रेजेंट है उन इलेक्ट्रॉन को शेल के कैपेसिटी के अनुसार अरेंज करना मतलब ही इलेक्ट्रॉनिक कॉन्फिगरेशन ऑफ दैट एलिमेंट. अंडरस्टूड? Got it? What is the electronic configuration of an element? Yes, everyone, you got? Okay. Each electron has a definite energy as per the shell in which it is present. प्रत्येक इलेक्ट्रॉन कडे तो ज्या शेल मध्ये प्रेझेंट असतो त्याच्यानुसार त्याची डेफिनाइट एनर्जी असते. ओके, जो भी इलेक्ट्रॉन एवरी इलेक्ट्रॉन विच इज प्रेजेंट इन द पर्टिकुलर शेल, किसी पर्टिकुलर शेल में जब इलेक्ट्रॉन प्रेजेंट होता है तो उस इलेक्ट्रॉन के पास उसकी कुछ डेफिनाइट निश्चित की हुई ऊर्जा या फिर एनर्जी उसके पास रहती है. एनर्जी ऑफ एन इलेक्ट्रॉन इन द फर्स्ट शेल दैट इज अ के इज द लोवेस्ट. सी, लोवेस्ट जो भी न्यूक्लियस के पास नियरेस्ट न्यूक्लियस के पास कौन सी शेल होती है, के शेल होती है। तो के शेल में जो भी इलेक्ट्रॉन होता है उसकी एनर्जी क्या होती है, लोवेस्ट। लक्षात ठेवायचं आहे, के शेल ही फर्स्ट शेल आहे, कारण न्यूक्लियसच्या जवळची शेल म्हणजे फर्स्ट शेल असं आपण अगोदरच पाहिलंय। के शेल ही न्यूक्लियसच्या जवळची शेल आहे आणि के शेल मध्ये जो इलेक्ट्रॉन असणार आहे त्या इलेक्ट्रॉनची एनर्जी लेवल काय असणार आहे, लोअर, लोअर सगळ्यात कमी, लोवेस्ट। ओके, energy of electron in the subsequent shell goes on increasing with the ordinal number of the shell. ओके, मग के नंतर, के चा ऑर्डिनल नंबर काय आहे सांगा मला, व्हॉट इज द ऑर्डिनल नंबर ऑफ के, सांगा, what is the ordinal number of k, 1. Okay, after that what shall come, k, l, m, n. Okay, then their ordinal number will also increase, 1 2 3 4 are their ordinal number respectively. त्यामुळे काय होणार आहे, क्या होगा उसकी वजह से जैसे ही शेल बढ़ता जाएगा उसके ऑर्डिनल नंबर बढ़ते जाएंगे, वैसे ही सब्सिक्वेंटली व्हाट विल हैपन, इलेक्ट्रॉन्स की जो भी एनर्जी है वो भी बढ़ती जाएगी। ओके, जसे जसे शेलचा नंबर इंक्रीज होणार, शेलचा इंक्रीज ऑर्डिनल नंबर इंक्रीज होणार, त्यानुसार त्याच्यामध्ये प्रेझेंट असणारे जे इलेक्ट्रॉन्स आहेत त्याची एनर्जी लेवल सुद्धा वाढत जाणार। गॉट इट, गॉट इट ऑल ऑफ यू? ओके, the electronic configuration of an element is such that the energy of all the electrons together is the maximum possible. See, इलेक्ट्रॉनिक कॉन्फिगरेशन ऑफ एलिमेंट, मग इलेक्ट्रॉनिक कोणत्याही इलेक्ट्रॉनचं इलेक्ट्रॉनिक कॉन्फिगरेशन कशा प्रकारे असतं की प्रत्येक इलेक्ट्रॉनची एकत्रित एनर्जी इज द मॅक्झिमम पॉसिबल, एकत्रित ऊर्जा कमीत कमी असायला हवी, अशा प्रकारे आपलं इलेक्ट्रॉनिक कॉन्फिगरेशन असतं। इलेक्ट्रॉन्स गेट अ प्लेस इन द शेल इन accordance with the maximum capacity of the electron shell in an atom and the increasing order of energy. See, जशी आपले जे शेल आहेत, ओके, वी हॅव द शेल, येस, शेल मध्ये इलेक्ट्रॉन ठेवण्याची जेवढी क्षमता आहे, जेवढी कॅपॅसिटी आहे आणि एनर्जी लेवल जशी वाढत जाते त्याचप्रमाणे इलेक्ट्रॉन्सला स्वतःची प्लेस मिळत असते। ओके, इलेक्ट्रॉन जिस शेल में प्रेजेंट है उस शेल में उसको उस शेल की इलेक्ट्रॉन होल्ड करने की जो भी कैपेसिटी है या फिर हमारे इलेक्ट्रॉन के पास जो एनर्जी है उस हिसाब से वो इलेक्ट्रॉन उस शेल में फिट होता है। Let us now look at the electronic configuration of atom of some element. The rows 1, okay, in the table 5.7, the rows 1 to 3 are filled in this table. Accordingly, you have to fill the rest of the table. Sorry. Let's see. Okay. Now let's see what they have asked us to do. आता आपल्याला काय सांगितलं आहे, काही एलिमेंट्स दिलेत आणि त्याच्या ऍटमचं इलेक्ट्रॉनिक कॉन्फिगरेशन आपल्याला दिलेलं आहे, त्यामध्ये 1 आणि 3 आपल्याला भरून दिलेले आहेत, बाकी आपल्याला करायचे आहेत। ओके, सी, atoms hydrogen, helium, lithium, carbon, nitrogen, oxygen, fluorine, neon, sodium, chlorine, argon and bromine. Symbols are hydrogen H, helium He, lithium Li, carbon C, nitrogen N, oxygen O, fluorine F, neon Ne, sodium Na, chlorine Cl, argon Ar, bromine Br. And number of atom present inside electron number in the atom, electrons present inside the atom, H1, He2, lithium 3, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, chlorine 17, argon 18, bromine 35. As you have already found out that K shell will contain only 2 electrons, L shell will contain only 8 electrons, M shell will contain 18 electron, and N will contain 32 electron. And in the last column you have to write the electronic configuration in the numerical form. Okay, so let's start. Hydrogen contains only one atom, so that electron will go inside K shell. Okay, कारण K ची capacity किती आहे 2 आहे. K मध्ये आपण 2 पर्यंत असणारे कोणतेही इलेक्ट्रॉन्स टाकू शकतो. ओके, यस. नाउ मग L मध्ये जाण्यासाठी काही राहणार का? L में कुछ जाएगा क्या? L, M और N में जाएगा क्या कुछ? हाइड्रोजन के केस में सिर्फ एक ही इलेक्ट्रॉन प्रेझेंट है. सांगा मला जाणार का? L, M, N या शेल मध्ये काही जाणार का? In the case of hydrogen where only one electron is there, nothing will go inside L, M, N. No, Hariom, nothing will go inside L, M, N. Next, helium. Helium K. Helium चे पण दोनच electrons आहेत, so it will go inside K shell only. Lithium has 3 electrons. See, lithium has 3 electrons, but K shell has capacity to hold only 2 electrons. So one electron is remaining, will jump inside L. Will jump inside L shell. Okay. Carbon. Who will tell me about carbon? Yes, who will tell me about carbon? Carbon has 6 electrons. How many electron will go inside K? Who will tell me about carbon? Yes, Nidhi, tell me.
Yes, ma'am. In carbon, shell K 2 and shell L 4
Very good. So
and
what
nothing
will be? Yes.
N.
Yes. So what will be the electronic configuration of that? 2, 4. Okay. Yes. Now see. Next is nitrogen. Nitrogen's electrons present inside nitrogen atom is 7. 7. How you will distribute it then? Who will tell me about nitrogen? 7 electrons. Yes, Hariom.
Yes, ma'am. Nitrogen K shell 2 L 5.
Good. K shell will contain 2 electrons of nitrogen and 5 electrons will go inside L shell. Okay, clear. Oxygen. Oxygen has 8 electrons. What about oxygen then? Yes, Hariom.
Yes, ma'am. Oxygen K shell 2 L shell 6.
Yes. Because L shell has capacity to hold 8 electrons, we can put inside till 8 electrons in the L shell. Okay. Now, fluorine. Fluorine has 9 electrons. 9 electrons. What will be the case of fluorine then? Yes, Hariom.
Yes, ma'am. K shell 2 and 8
Yes.
shell 7.
L shell 7. 7. Okay, fine. Good. Now, neon. Neon contains 10 electrons. Yes, anyone else? Mansi, will you try? Don't you
Yes,
have
ma'am.
understood now?
No, ma'am. My network issue was there, so I have left the meeting.
Okay, so you want me to explain again? Just see, we have, okay, I will explain by showing. See, we have found out now that K shell will contain only 2 electrons, L contain 8, M contain 18 and N contain 32. Yes, we have found out that. So here in this table, what they have given us? Atom, its symbol, the electrons present inside the atom and its electronic configuration we have to find out. So how you will find out the electronic configuration of that particular atom? See, hydrogen contains only one electron. So that electron will go inside K shell because K shell has a capacity to hold 2 electrons. Now helium. Helium contains 2 electrons that will also go inside K shell. But lithium contains 3 electrons. K shell has capacity to hold only 2 electrons. So what about that one electron? That one electron which is left behind from that number 3 will jump into L orbit. Okay, like that. Carbon has 6. So 2 will go inside K and 4 will go in the L. Nitrogen has 7. K will contain 2 and 5 will go inside the L orbit, L shell. Oxygen contain 8. Yes, oxygen contain 8. So 2 will go in the K and remaining 6 will go in L. Fluorine contains 9 electrons. So 2 will go in K and 7 will go in L. Now Mansi, can you answer for neon?
Yes, ma'am.
Neon contains 10 electrons. Yes.
K shell will be 2 and
Yes.
L will be 8.
Okay, fine, good. Now, what about sodium? As L contains only, L have the capacity to hold only 8 electrons. What about the sodium then? Yes, Hariom?
Yes, ma'am. Sodium K shell 2, L shell
Yes,
8, and M shell
yes,
1.
very good. See, now L shell has capacity to hold only 8 electrons. Now, that's why the one is remaining will jump inside the M shell, M orbit. Okay. Now, chlorine 17. Chlorine 17. Who will take a try? Nidhi, will you?
Yes, ma'am.
Yes.
Shell K 2, shell L 8,
Hmm.
shell M 7.
Good. Because shell M has the capacity to hold 18 electrons. So, that 7 electron will go inside shell M, will jump inside shell M. Now, argon. Argon has its electron numbers 18 inside that. What will happen with argon then? Yes, Mansi?
K shell will be 2, L shell
Hmm?
will be 8, and
Hmm?
M shell will be 8.
Good. Bromine. Hariom, bromine.
Yes, ma'am. K shell 2, L shell 8, M shell 18, and shell 7.
Very nice. Okay, now you got how to write this table, how you will complete that. Yes. Okay. In the last column, you have to write the electronic configuration also. Okay. In the last column, how you will write? Like for argon, you will write 2, 8, 7. For bromine, you will write 2, 8, 18, and 7. Okay. Yes. Now you can complete it on your own, right? See. The electronic configuration in the numerical form contains numbers separated by commas. ओके जेव्हा आपण इलेक्ट्रॉनिक कॉन्फिगरेशन न्यूमेरिकल फॉर्म मध्ये लिहितो यहाँ पे हमने क्या किया न्यूमेरिकल फॉर्म में लिखा इलेक्ट्रॉनिक कॉन्फिगरेशन तो नंबर को सेपरेट आउट करने के लिए हमने क्या यूज किया बीच में कॉमा यूज किया Here the numbers indicate the electron number in the shell with increasing order of energy. For example, the electronic configuration of sodium is 281. ओके देखिए हमने क्या किया इलेक्ट्रॉन को अरेंज किया इलेक्ट्रॉन का कॉन्फ़िगरेशन लिखा मतलब इंक्रीजिंग एनर्जी लेवल के हिसाब से उनको हमने अरेंज किया it means that the total 11 electron in sodium are distributed 2 in the shell K 8 in the shell L and 1 in the shell M that we just now did yes the electronic configuration of an atom can also be represented by shell diagram as shown in figure 5.8 see दिस इज द शेल डायग्राम शेल डायग्राम में देखिए क्या किया है सोडियम में हमने के में कितने डाले हैं 2 डाले हैं ओके देन एल में कितने इलेक्ट्रॉन्स डाले हमने 4 इलेक्ट्रॉन्स डाले और एम में कितने गए ओनली 1 इलेक्ट्रॉन सो दिस इज द शेल डायग्राम ऑफ इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ सोडियम क्या करना है आपको सिर्फ सर्कल्स निकालने हैं जितने भी आपके ऑर्बिट्स है जो भी अपने शेल यूज किए हैं के, एल और एम शेल हमने यूज किए, राइट। तो हमने 3 सर्कल निकालने हैं और उसमें सिर्फ इलेक्ट्रॉन पुट करने हैं। दिस इज द शेल डायग्राम. Like this also you can represent your electronic configuration of atom. Okay, got? न्यूमेरिकल फॉर्म मध्ये आपण टेबल मध्ये जे लिहिणार आहेत, that we are the one we are going to write it in a table will be our in the numerical form. That electronic configuration will be in a numerical form. And this just now I have show you, this one will be the shell diagram of your electronic configuration. Okay. Okay, our next topic is valency and electronic configuration, that we will study in the next lecture. Okay, do not take extra burden. What we have learned, how to write a electronic configuration and how to calculate that. Okay, how to write a electronic configuration in numerical form and in the shell form also. If I have okay, can you write the, yes, we will add one thing to you. You just now have completed this table, right? You have to write it in your notebook and just draw numerical that shell diagram. Okay, just draw shell diagram. Mark it over there. Shell diagram for carbon. Make marking in your textbook. Draw shell diagram for carbon, then neon, chlorine, and argon. Yes, carbon, neon, chlorine and argon. Will you do that? Yes. Please ध्यान दीजिए सिखाते वक्त, as you three are always interested in answering and learning very nicely. This is going to be very useful in your 11th and 12th. Okay, in your 11th and 12th chemistry, it is going to be very useful. Cause हमने इतने अर्ली एज में ये नहीं सीखा था. We get to know this when we went to our 10th, 11th and 12th. Okay, you are learning this in your early ages. So आत्तापासूनच खूप लक्ष द्या, बहुत ज्यादा ध्यान दीजिए, so that you can keep it mind this and you can it can be very useful when you give your CETs and all. Yes, in your after your 12th, it will be very useful in your 11th and 12th chemistry. So very nicely pay attention whenever I am teaching you. If you are not getting any point, you can clearly ask me. Okay. Okay, so will you do your homework now? Okay, so we are going to stop over here. You can leave now. Bye bye. Thank you for answering and patiently listening. Yes, welcome. Bye.
Bye, Miss. Thank you, Miss.
Bye bye. Welcome.